Okay, I've got the record on. Okay, so we want to do this division of fractions. And we know there are two things we have to do. First of all, division means take the reciprocal of the second fractions and then just do a multiplication. And since all these things are polynomials, we want to factor our polynomials. So if we can possibly cross cancel, we want to do that before we actually do the multiplication. So as I'm going to do both of these things at the same time, I'm going to leave the 2x minus 3 alone because there's not much you can do with that. It's as factored as you possibly can. Then I'm going to look at this x squared minus 10x plus 25, and that's a trinomial that I'm going to try and use the AC method to factor. I'm going to do that down here. My AC happens to be 1 times 25, which is positive 25. And my B is this number in front of the x, which is negative 10. And since we're looking for numbers that are going to multiply to 25, it's going to be positive. So both numbers are going to have the same sign. This being negative means they're both going to be negative, because a negative times a negative will give us positive. And I think it's obvious that the number should be negative 5 and negative 5, because negative 5 times negative 5 will give you positive 25, and negative 5 plus negative 5 will give you negative 10. So this x squared minus 10x can be written plus 25 can be, we can break up the negative 10x to negative 5x and negative 5x. So here are 4 terms in our grouping. Our first group has a common factor of x. So that's x times x minus 5. And my second group has a negative 5 as a common factor because this starts with a negative 5. So this is negative 5 times x, and negative 5 into positive 25 is also negative 5. So it turns out that this x squared minus 10x plus 25 can factor into x minus 5 times x minus 5. In other words, this is really x minus 5 squared. It's probably better for when we're doing the fractions to have them separate, but this really is the binomial x minus 5 squared. Okay, now let's go on to the other fraction. We're changing this to a multiplication. So we're now looking at our top being 25 minus x squared, but of course we want to factor that. And 25 is a perfect square and x is a perfect square, so it's the difference of squares. So we can factor that into 5 plus x and 5 minus x. And finally, the denominator is going to be this 10x minus 15, but of course we can factor that as well. It has a common factor of 5. So I'm going to do 5 times 2x minus 3. So now I've changed the division to a multiplication, and I'm ready to cross cancel wherever I possibly can. So first of all, I have a 2x minus 3. I'm going to go straight across. 2x minus 3, I can cancel that with a 2x minus 3. Remember, any numerator with any denominator. Now I'm putting a 1 here because once there's a numerator is totally gone, I have to remember it's not a 0, it's a 1. I don't have to put the 1 here so much because there's a 5 still here, and a 5 times 1 would still be 5. Okay, now let's go on to the 5 plus x. Is there anything in the denominator that I can cancel out with 5 plus x? And the answer is no, because the only thing that can cancel out with a 5 plus x is another 5 plus x or an x plus 5. The only thing can be is switched. The order can be switched. Notice with a plus, it doesn't make a difference if it says 5 plus x or x plus 5. It's the same thing. They would just totally cancel out. but there's nothing to cancel this out, but I do have a 5 minus x. And there's no other 5 minus x, but there are x minus 5. So I can cancel out the 5 minus x with one of the x minus 5, remembering that I must put a -1 in and I prefer doing it in the numerator because these are not identical, they are negatives each other. So when you canceling out a binomial that's switched order with a minus, you have to put a -1. And now there's nothing left for us to cancel out. So let's see what we're left with. We have this 1 times this. Remember, this is a multiplier, right? We're not subtracting 1, we're multiplying by -1. 1 times -1 is -1 times 5 plus x. That's the top. And on the bottom, I have an x minus 5 times a 5. So I'm going to put the 5 first. Usually we put the monomial first and the binomial second. You could leave it this way, or with a -1 in the numerator, you could just put it as a negative in the front of the fraction. This means the same thing. So if you wanted to, you could have also removed the parentheses on the bottom, but it's not necessary. But again, when you have a negative in a numerator or a negative in a denominator as a factor, multiplying the whole thing, you could just move it to the front. Any questions about this? Adina, that just remember that negative there has to be in front of the whole fraction, not just in front of the 5. It's hard to, when you're typing it, it's hard to tell that. That's why you notice I either put a negative with a parentheses or put it right in front of the whole fraction. All right, so this takes care of basically multiplying and dividing of fractions. What we're going to be continuing with today is adding and subtraction of fractions, specifically when the denominators are not the same. How do we do that? Just before I start, I just want to remind you about the midterm. The midterm will be available on Blackboard, just like test 1 was. It's pretty much the same setup. It's going to be on Blackboard. You will see it in a section that says midterm specifically. It will be available starting on Thursday at 2 p.m. In other words, basically after this class is over, and it will be available until Friday at 4 p.m. In other words, I'm giving you basically 24-hour period for you to take it. Again, like this one, this test 1 on Blackboard, it is 20 multiple choice questions, and I'm giving you, I think, 75 minutes. Again, it's really supposed to be 60 minutes, but I'm giving you a little bit of leeway because sometimes it takes a little bit of time to get your computer set up, etc. Once you start the test, you must complete it in one sitting. It will close automatically after 75 minutes, and it will not be available after 4 p.m. on Friday. So don't think you can start the test at 3:30 and have an hour and a half from there. It's going to close at 4 o'clock no matter what. So make sure you allow yourself enough time to sit for the exam and enough time for you to do it where you have one stretch. You cannot break it up. It has to be all done in one stretch. Again, exactly the way, it's very similar. That was the point of that test, to get you prepared for tests on Blackboard. Any questions about that? Okay. So let's go on to what we want to talk about today, and that's adding and subtracting of fractions that don't have like denominators. If anybody has any questions that they want to ask me pertaining to what's going to be on the midterm, if there was one topic that you wanted me to review, please send me a text telling me what the topic is, and I'll spend some time at the end of this period or at the beginning of next period doing that. So again, if anybody has any questions they want to ask pertaining to topics on the midterm, again, don't forget that there is SI sessions. They actually run from 1 to 3, I think Monday through Friday, but obviously between 1 and 1:40, you're busy here, but right, you can get on right after this class to Shireen's Zoom tutoring. Again, I'm sure you will have her email. If anybody has any interest in that. Again, if you have topics that you want to review, she's an excellent tutor. She really knows how I teach things, and she knows the course very well, and she does a good job. So that's the other option you have. Okay, so let's start with a question that looks like this. Suppose I had 2/3x minus 5/6x squared plus 1/12x. Let's say it. I'm speaking this up as I go along. Suppose I wanted to combine these fractions. Now, if you recall what we said last week, in order to add or subtract fractions, what we have to have is something called an LCD, a least common denominator. We have to have the same denominator on each fraction before we can combine their numerators. And the question is, how do we find this LCD? So first of all, when your denominators are all monomials, single terms, then in order to find the least common denominator, you first look at the number parts, the 3, the 6, and the 12, and see if there's any number that all of them will go into. Now, usually what I do is I take the largest number and see if the others go into it evenly. And 3 does go into 12, and 6 does go into 12. So in terms of the coefficient part, the common denominator is going to be 12. To get the variable parts, the number part, the letter parts, I mean, the literal parts, look at your letters. The only letter I see here is an X. Take the X with the highest exponent, which is x squared. Your common denominator then is 12x squared. So let's go through this again. To find the LCD of when everything is monomials, first we'll find the LCD of the coefficients, which in this case is 12, and then find the LCD of the variables by just simply taking the highest exponent of the variable that you see. Okay, once you have your common denominator, you're going to rewrite your problem with everything having that same common denominator. In other words, I'm going to have to I changed the denominator. I'm going to have to change the numerator as well. Remember, you don't change the value of a fraction when you multiply the top and the bottom by the exact same thing. Numerator and denominator multiply by the same value doesn't change the value of the fraction. So here's what we do. We divide the original denominator into the LCD. And I do that by dividing part by part. The numbers into the numbers. 3 into 12 gives me 4. X into x squared gives me x. In other words, 3x was multiplied by 4x to get the 12x squared. Take that 4x and multiply it by the numerator. 4x times 2 is 8x. In other words, I've changed the fraction 2 over 3x to 8x over 12x squared. Notice if you would have reduced this, that's what you get, but you don't want it reduced because you need it to have the 12x squared on the bottom. Okay, go to your next fraction and do the same thing. So the 6 divides into the 12 gives me 2. You know, and I'm going to put this in a parenthesis, so I'm just, no, it's just helping me get to the next step. The x squared into the x squared cancels out. In other words, 6x squared into 12x squared is 2, so I have to take the 2 and multiply by the 5, that gives me 10. And finally, I do the same thing with my last fraction. 12 into 12 cancels out. X into x squared gives me x. In other words, 12x times x gave me the 12x squared. I take that x and multiply by the 1, and that gives me 1x or x. Once I have all the same denominators, I just work with the numerators. What are my numerators? 8x minus 10 plus x, which I can combine. 8x plus x gives me 9x minus 10. And I put that over the common denominator, 12x squared. I then ask, can I reduce anything? But I can't factor the numerator, so there's nothing. This is a binomial, this is a monomial. I can't reduce that. Here is my answer, 9x minus 10 over 12x squared. So that's how we combine fractions by first finding their least common denominator and then combining the like term, rewriting each of the fractions with that common denominator, combining just the numerators. Once I've got a common denominator, just work with the numerators and then put that final, don't forget to put the final answer over the LCD. If you can reduce it, then try and reduce it. Okay. Let's see if we can do an example with where the where the denominators are not monomials, but they're polynomials. Let's see if we can do something like that. I'm going to do a couple like that, and then I'll give you some time to try yourself. Okay, let's see if we have, let's try this problem. One more, then I'll give you to try, and while you're trying that, I will take attendance. So let's look at this problem. Suppose I have 6x plus 7 over 4x squared minus 1 minus 5 over 2x minus 1. Okay, so we're going to look at this problem and we're going to see if we can subtract these two fractions. And on the side, as I'm doing it, I'll give you the steps that I'm using so that you can keep in touch, keep track of what we're doing. The first step we have to do is, again, find our least common denominator. In this case, we don't have the same denominators. And on top of that, our denominators are not monomials. We happen to have polynomials as our denominators. So in order to find the LCD, the first thing you're going to do is factor all your denominators. Just your denominators. Even if you could factor the numerators, you don't want the numerators factored. Your only first concern is the denominators. So let's look at our denominators. Can I factor 4x squared minus 1? And the answer is yes. There's no common factor, but 4x squared is 2x times that, 2x. And 1 is 1 times 1. This is the difference of squares. In other words, this is 2x plus 1 times 2x minus 1. And putting a line through this so I know this is what I'm working with. My next denominator is 2x minus 1. There's nothing that I can do with that. It's as most factored form. Okay, so your next step is to circle all the different factors. Circle all different factors. Okay, so I'm going to do that with a marker. So what I do is I start with my first denominator and I circle all the factors of that first denominator. So there's a 2x plus 1 and a 2x minus 1. Those are my first two factors that I circle. I then go to my second fraction and circle anything that has not been circled already. Now this is a 2x minus 1. Have I already circled the 2x minus 1? Yes, it's right here. So therefore I don't have to circle it. So what is my LCD? My LCD is all the circled factors. In other words, what have I circled? I circled 2x plus 1 and 2x minus 1. That's my LCD. So my next step is going to be to rename the fractions. Change the numerators because I've changed the denominators. So once I have my LCD, I rename my fractions. Just been writing it, rename. And we do it exactly the way we did before. We take our original denominator and divide it into the LCD. Now that is going to be quite a bit easier because it's just, since everything is already factored, it's just a matter of checking off. If I divide this into this, this will be gone, this into this. In other words, the 2x plus 1 times the 2x minus 1 goes into the 2x plus 1 times the 2x minus 1. There's nothing left over. In other words, all you have to do is compare. What this is here, this is here. I haven't multiplied this denominator by anything. I didn't multiply the denominator. I don't have to multiply the numerator. The numerator stays 2x plus 7. In other words, that first fraction, I changed nothing. I don't have to do anything. What about the second fraction? In the second fraction, I see, I compare the 2x minus 1 into the, if I divide this into this gets canceled out. What I'm left with is a 2x plus 1. In other words, the division is very easy to do because all you have to do is cross out the things that are the like. So the only thing I was left with is a 2x plus 1. So I have to take this 5 that was there originally and multiply it by this 2x plus 1. So let's go through that again. When we're renaming the fraction, check off what was there originally and multiply by anything that is not checked off. Everything here is checked off. I don't have to multiply that 6x plus 7 by anything. It stays 6 plus x plus 7. Over here, the 2x minus 1 got checked off. And that was there originally. What wasn't checked off was the 2x plus 1. So that's when I have to multiply the 5 by. So now we just work with the numerators. What are my numerators? My numerator is the 6x plus 7 minus the 5 times the 2x plus 1. I'm going to simplify this and combine everything. And when after I've done that, I will put it over the common denominator. So this will give me 6x plus 7 minus 10x minus 5. I'm removing the parentheses using distributive, which gives me, let's just going over here, 6x minus 10x is negative 4x. And 7 minus 5 is plus 2. And I put that over the common denominator of 2x plus 1 and 2x minus 1. And I'm left with this negative 4x plus 2 over 2x plus 1 times 2x minus 1. Now I look at my numerator and actually I could factor that. As a matter of fact, there's a common factor of 2. And since it starts with a negative, it's actually not just a common factor of 2, it's a common factor of negative 2. My last step is to try and factor everything to see if I can reduce it. So I'm going to factor out a negative 2. Negative 2 into negative 4x is positive 2x. Negative 2 into positive 2 is negative 1. I factored my numerator into negative 2 times 2x minus 1. And that's over the 2x plus 1 times the 2x minus 1. And if I notice now, I have a common factor of 2x minus 1 on top and on bottom. So my final answer becomes negative 2 over 2x plus 1. Again, I could leave the negative on top or put the negative in front of the fraction. Any negative that applies to the whole numerator or to the whole denominator can be put in front. Either of these answers are perfectly good, but that's how we have to do it. We have to find a common denominator by factoring everything. Once we have everything factored, then take all the different factors and make that your common denominator, and then compare your original denominator to your LCD. If you see anything, when you divide one into the other, whatever you're left with is your answer. That's what you have to multiply your numerator by. Here, nothing was left. I didn't have to change the numerator. Here, when I divided this into this, I was left with a 2x plus 1. So that's what I had to multiply that 5 by. And then I just work with the numerators. Notice my whole point is with the numerators not to factor, but to combine the like terms. I only factor after I have it as a common denominator. This is probably one of the hardest things that we learn. This term, it's complicated. It's a lot of steps. I want to give you one to try on your own while I'm taking attendance. Okay, look at this one. X over x plus 3 minus 18 over x squared minus 9. Okay, let's see if you can do this example of combining those two fractions into a single fraction. Now I'm erasing this part, but I'll leave those hints on so you'll remember what you have to do. Okay, just listen for your name. Maury. Hi, good afternoon. Chelsea. Chelsea here. Ariana.
Here.
Hi. Thank you. Adina. Adina, I know you're here because
I'm here.
you keep me on my toes. Thank you. By doing the problem so promptly. Lachey.
I'm here.
Kayla.
Here.
Hi, how are you?
I'm good.
Yeah. Terrence. Terrence.
Yeah.
Terrence, did you get to do the test? I didn't notice if you did or not.
I'm pretty sure I did it.
Okay, good. I'm going to be checking, by the way, I'll be checking right after the midterm. I'm going to be checking everything, and I'll be sending you individual emails as to where you stand at this point in the course. It doesn't mean it's your mark for now, but it's your mark for the end of the course. But it definitely is an indication as to where you are. We're pretty much at the halfway point, so probably next week after your midterms, you will be look out for that kind of email. Karide here.
Here.
Hi. Kizia. Kizia here.
I'm here. Hi.
How are you?
I'm good. How are you?
Good. Faith. Faith Diggs? Faith here? Ethan? Hi, was that Faith? Hi, somebody was. Is Ethan here?
Here.
Hi, how are you? Isabella? Isabella?
Frozen. Here.
Hi, Isabella. Okay, thank you. Serenity?
Here.
Hi, how are you? Reggie?
Here.
Hi.
Hello.
Zamia? Zamia Grady? Brandon?
Here.
Hi, Brandon. Michaela? Michaela here? Seraphine? Seraphine?
I'm here.
Hi. Marissa?
Here.
Hi. Renee?
Here.
Hi. Sky?
I'm here.
Jaden Roberts? Jaden Roberts? Kennedy?
I'm here.
Felicia Simon?
I'm here.
Natalia?
Here.
No. Michael? Michael Todd? Hi, Michael. Cassidy? Hi, Cassidy. Megan?
Here.
Kalia Watson? Lauren Whaley?
Here.
And Kayla Zachary? Okay, now something's wrong because I see 28 people here and I only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm missing 3 people. If you didn't hear your name called, please send me a message. Let's see. Okay, Michaela, I see you're here. Okay, Chelsea, I hadn't seen you here either. Okay. Okay, here are the people are marked absent. If you're here, just send me a text. Faith, Zamia, Jaden, Kalia, and Kayla Zachary. Anybody here that I just called? Okay. All right, I see that a few people have sent me the answer also. So let's see if we can do the problem. Okay. The first thing we're going to want to do is find the least common denominator. And since our denominators are polynomials, we're going to have to factor those that are factorable. The x plus 3 can't be factored any further, but the x squared minus 9 is the difference of squares, and we can factor that to x plus 3 and x minus 3. That kind of factoring comes up very often, the difference of squares. And that tells us that if we want to find our LCD, we're going to go to our first denominator and circle everything that's over there, which is the x plus 3 only, and then go to our next denominator and circle anything that has not previously been circled. That's what it means, circle all the different factors. So I have an x plus 3, I don't have to circle this again, but I haven't circled my x minus 3. So now I have everything that, all the different factors circled, take them together, which is the x plus 3 and the x minus 3. That is my common denominator. Okay, so we found our common denominator. We now want to rename our fractions. And we do that by comparing my original denominator with my LCD. So here I have the x plus 3 that I have. What I didn't have, what's new here, is x minus 3. So I have to take my x that was there originally and multiply it by the x minus 3. I multiplied in the denominator by x minus 3. I've got to do the same thing in the numerator. Now I do the same thing with my second fraction. So my x plus 3 is here and my x minus 3 is here. Both of these things are here. My new denominator is exactly what my old denominator is. I haven't changed everything in my denominator, so therefore I'm not changing my numerator. I'm leaving that the 18. And therefore what I'm left with is, if I just look at, remember now I just ignore the denominator for the most part, and I do the x times x minus 3 minus 18. And I've got to simplify this by removing all the parentheses. That gives me x squared minus 3x minus 18. And that I put over my common denominator of x plus 3 and x minus 3. And in order to do the final step of simplifying, I've got to factor the numerator if I can. And this is a trinomial, so I'm going to use my AC method. My AC happens to be negative 18, and my B happens to be negative 3. Now, since it's negative, it means one number is going to be positive and one number is going to be negative. and we need them to multiply to 18, but when we combine them, we should get a -3. I think you can tell that it's a +3 and a -6, because +3 times -6 gives you -18, and +3 plus -6 gives you -3. In other words, this x squared minus 3x minus 18, we're going to break up into x squared minus 6x plus 3x minus 18. So we can factor out in the first group an x, and we get x minus 6. And in the second group, we have a 3 common factor, so we can factor out that 3, and we get x minus 6 as well. So this x squared minus 3x minus 18 ends up being x minus 6 times x plus 3. And that's over the x plus 3 and the x minus 3. And I see the x plus 3 on top and the x plus 3 on bottom can cancel. So my final answer comes out to be x minus 6 on top and x minus 3 on the bottom. Again, it's a lot of work, but just be careful. The thing is to be careful and you will get the right answer. Okay, and I do see that some people did get that answer. Excellent. Okay. I think let's go on to something. Would you like to do one more like this, or should we go on to something new? Okay. Look out. Nobody seems to care if we do more of these, so let's go on to something new. You don't forget to look out for your Delta math, because there will be homework on these type of examples. Again, we'll review this again on Thursday, obviously before you start your midterm. Again, this is not on the midterm. This is post-midterm work. The fractions are all post-midterm. These type of fractions. These are what we call rational expressions. What I want to go on from here is to talk about what happens when we have equations with fractions. We've done a little bit of it before, but I really want to go very carefully, and that's a very important topic, how to deal with what we call rational equations, equations that have fractions. So let's start with one type. Suppose I gave you something that looks like this. 6 over a minus 4 equals 3 over 8. We want to solve this equation. It's an equation, I can see it because it has an equal sign, and we want to find the value of a that will make this a true statement. And it turns out that this is a very particular type of equation that has fractions in it. It is something called a proportion. Not important for you to remember that name, But what's important is that you realize that on each side of the equation, you have exactly one fraction. When you have that situation, when you have a proportion, one of the ways to solve it is by the method that's called cross multiplication. What you're going to do is you're going to multiply each numerator with its opposite denominator. In other words, that's why it's called cross, because you're going across the equal sign. You're going to multiply the 6 times the 8. And that's going to give you, that's going to be equal to the 3 times the a minus 4. Go across the equal sign. Notice you will still have an equal, but it'll be the numerator times the denominator equaling the numerator times the denominator. Now, the obvious advantage of this is that we no longer have fractions. Most people don't adore fractions. They don't love working with fractions. I guess there are some people that do. So we'll see that basically our method of solving equations that have fractions is to somehow try and get rid of those fractions. Okay. Once we have this new equation that is equivalent to our original equation, we're going to solve this obviously by multiplying and removing the parentheses. So 6 times 8 gives me 48. And here I'm using my distributive property. That's going to give me 3a minus 12. I'll then bring the 12 to the other side. This will give me 60 equals 3a. And divide by 3. So it turns out that my a is equal to 20. The first step is to cross multiply, and that makes the whole equation much simpler to solve because we no longer have any fractions. Okay, let me give you one to try like this. See if you can do one of these. Suppose I gave you this equation. Six over x minus 5 equals x over 4. Let's see if you can solve that equation. Yes, that's an equal sign. This is an equation. It's 6 over x minus 5 equal x over 4. Okay, I see we're getting some answers already. Okay, so let's see if we can work on this together. Thank you, Reggie. Those answers did look good. Again, we have a proportion, a single fraction equaling a single fraction. We're going to cross multiply. We will get 6 times 4 equaling x times x minus 5. Doing the multiplication, that gives me 24 equals x squared minus 5x. This is a quadratic equation now because we see that x squared. And when it's a quadratic equation, remember we want to get it equal to 0. So I'm going to subtract 24 from both sides because here my x squared is positive. I would like to work it with the x squared being positive. It's always easier that way. So I'm going to subtract 24 from both sides, which will give me a 0 equaling x squared minus 5x minus 24. And we have to factor this. It's a trinomial. And therefore, I'm going to use my AC method. My AC is negative 24, because this is 1 times negative 24. My B is negative 5. So I'm looking for 2 numbers, one obviously positive and one negative, because the answer that are going to multiply to negative 24, but when we combine them are going to give me negative 5. I think you could see that it's 8 and 3, and it's going to be a negative 8 and a positive 3, because negative 8 times positive 3 times negative 8 will give us negative 24, and positive 3 minus 8 will give us negative 5. In other words, this will be x squared minus 8x plus 3x minus 24, which factors to x times x minus 8, and 3 times x minus 8. So we have this x minus 8 times x plus 3. That's equal to my 0. Remember, I take each one separately and set it equal to 0. So that'll give me x minus 8 equals 0, which if we add 8 to both sides will give us x equal to 8. And x plus 3 equal to 0 which if we bring the 3 to the other side, will give us x equal -3. So our two answers are 8 and -3. The reason we got two answers for this one as opposed to just one answer was because we ended up with a quadratic equation, which we didn't know until we did that cross multiplication. So this is one method we can use to solve rational equations that have fractions. Again, it depends on the fact that what we have is a proportion, a single fraction equaling a single fraction. So let's just see what would happen if we don't have a proportion, but we have fractions. Okay, suppose I ask you this question. I have 5/8x plus 5/x equals 1/4. This is an equation that has fractions in it, but it's not a proportion because on the left side of this equation, I don't have just one fractions, I actually have two fractions. So, one concept would be to try and combine the two fractions into a single fraction and then cross multiply. But I'm going to show you a more efficient method that can be used, and actually this method could even be used with proportions as well. This method is the least common denominator method. Just like we did with adding and subtracting fractions, the first thing we're going to have to do is find the LCD. Okay, now in this case, all my fractions happen to be monomials. Remember, when they're monomials, I can do the number part, the coefficient part separately, and the literal part, the variable part separately. So if I look at the numbers, I have an 8. Well, here it's obviously a 1 and a 4. The common denominator of those three numbers is obviously 8. Remember what I told you, take the biggest denominator and see if the others divide evenly into it. And 1 divides into 8 and 4 divides into 8. So 8 is the LCD of the numbers, but there are variables here as well. I have an x, well, here no letter. The highest exponent of the variable that I see happens to be x to the 1 or just plain x. Our LCD is 8x. Okay, so just like we did with adding and subtracting, we find our common denominator. But now what we do is we put that common denominator, put it over 1, and multiply the whole equation by that common denominator. Use it as a factor. Multiply everything by the common denominator over 1. So we're going to multiply 8x over 1 by 5/8x plus 5/x equaling 1/4. You're going to have to multiply both sides of the equation. Remember, when you multiply or divide both sides of the equation by the same thing, it doesn't change the value of your fraction. Doesn't change the value of your equation, I'm sorry, your equation. Now, in order to multiply by this 8x over 1, I have to use the distributive property. So here's what I'm going to do. I'm going to have 8x over 1 times 5 over 8x plus 8x over 1 times 5 over x equals 8x over 1 times 1 over 4. Notice you have to multiply by every single term. You have to distribute it to everything on both sides of the equation. And we really have 3 multiplications to do. I first have to multiply the 8x over 1 times the 5 over the 8x. Now remember, these are fractions. We try to cross cancel. Notice there's an 8x here that can cancel out with an 8x here. Everything's gone here, so I'm putting 1s here. So I get 1 times 5 over 1, or just 1 times 5, which is 5. Remember, when the denominator is 1, I do not have to put it in. Okay, my next thing, it's going to be plus. Over here, the x cancels into the x, and what I'm left with over here is an 8, and I have to multiply the 8 times the 5, and that gives me 40. Remember, the denominator again is 1, so I don't have to put it in. That equals, over here, the 4 cancels into the 8x. This leaves me 2x, and 2x plus times 1 is 2x. Notice, since we multiplied everything by the LCD, the denominators will all cancel out. But you have to do this each one separately. Each is a different step. This times this, this times this, this times this. Of course, now we have a very simple equation, because the whole point of this is to be able to get rid of the denominators, to end up with something that's not a fraction. So here I have a 5 and a 40, which is 45, equaling 2x. So to find my answer, I divide both sides by 2, and my answer is 45 over 2. That's my final answer. So this is how we solve an equation which has variables even in the denominator. I'm going to give you one to try. Again, we're only working with monomials. Next time on Thursday, we'll work with binomials and trinomials in our denominator and see how that will work out. Well, let's see if I can give you one to try and see if you can get the answer. So let's look at this one. 1 over 2a equals 2 over a minus 3 over 8. Okay, I'm going to give you a few minutes to try that. See if you can solve for a.
Wait, Professor, we're gonna solve for A, right? You said.
We're solving for A.
Okay.
Okay, I see somebody already has an answer. I'll give you a couple of more minutes. Reggie, it looks like good. Okay, let's see if we can work on this together and then we'll call that a day. Again, we have one fraction over on this left side, but on the right side, we have two fractions. So we're going to use our common denominator method. So we're going to start, since our denominators are monomials, we're going to first look at the numbers. There's a 2. Obviously, this is a 1 and this is an 8. They all go into 8. And this is an A, and A, the highest exponent we see is A to the 1. So 8A is my common denominator. I'm going to put it over 1 and multiply everything by 8A. Which means I'm going to have to distribute this 8A. So I'm going to have 8A over 1 times 1 over 2A equal 8A over 1 times 2 over A minus 8A over 1 times 3 over 8. Okay, let's see over here. Here the 2, it goes into the 8, 4, and the A's all cancel out. So I have just 4 times 1, which is 4. Here the A cancels into the A. This leaves me 8 here, and 1 here. And 8 times 2 is 16. Remember, my denominators are all turning out to be 1, so I don't have to put them in. Here the 8 cancels into the 8A. It leaves me A. So I have negative A times 3. That's negative 3A. And this leaves me with a really simple equation to solve. I'll bring this 16 to the other side. Okay, let's go over here. Working over here. 4 minus 16 is negative 12. Equal negative 3A. And I'll divide by negative 3. So that I get A equals 4, which is perfect. That's what you got, Reggie. I'm glad to see that. Okay, and Ariana, yes, thank you. Those are perfect. Okay, let's not forget, the midterm is Thursday. You can access it after class at 2 o'clock, and it'll be available until 4 PM on Friday. Set aside a 75-minute period where you can take the test in that, with actually 26-hour period, section of time. I hope everybody, if you have a problem, you can't do it in that time, just email me. But I am assuming that everybody will find some time in between Thursday afternoon and Friday, pretty much a whole day, to do the exam. We're having regular class tomorrow. The test is sometime is outside of class. That's what I was told to do. Also, make sure you look on Delta Math to see if there's any homework that will be due for Thursday. And I will see you on Thursday, regular class. Again, if anybody has any questions on anything pertaining to the midterm, any topic you'd like me to do, you can either email me ahead of class or you can ask me right in class, and I will spend some time reviewing anything that you feel you need to go over. Again, don't forget to make sure you're doing all your homeworks on Delta Math and you're keeping current with homeworks and tests. And have a good day. I will see you on Thursday. I'm ending the class now, okay?
Bye, Professor. Have a good one.
Bye-bye. Have you too.